All right, so here we have the structure of a nephron again, and I've drawn it up here just to remind you of the various parts. We've been talking about this thing right here. I didn't draw in, we would have the glomerular capillary here, and we would have the efferent arteriole coming in and feeding into something we call the peritubular capillaries that are all over this thing. Now, as we talk about this second process, this process of reabsorption of materials, it's important to understand what we're talking about. We said we have filtered all kinds of stuff. We have filtered all kinds of materials, the glucose, anything that is of the small enough molecular weight is filtered out, and it has to be brought back into the system of capillaries, the peritubular capillaries. So you have to understand that surrounding the proximal convoluted tubules, the loop of the nephron, and the distal convoluted tubules, we have the peritubular capillaries. And as we talk about reabsorption, that's where we're talking about. It's being put back in to the blood plasma. Now, one of the things that, of course, is present in your blood in relatively high concentration is glucose, blood sugar. And so most of the nutrient type materials, amino acids, that kind of thing, they're going to be recovered very rapidly through active transport. It's going to be using energy to put them back in. And this reabsorption of the good stuff is going to be happening here in the proximal convoluted tubule, the portion of the tubule next to the nephron. So we have all of this kind of material is going to be actively transported back. Another thing that is going to be actively transported back and is going to be very important is going to be sodium. But first, before I talk about sodium, I'm going to talk a little bit about glucose. So if you have a normal amount of glucose present in your blood, and the numbers are 25 or less to be non-diabetic, and it's I'm not sure of the units, but anyway, so anyway, if you have a proper amount of glucose in your blood, what happens is the glucose gets filtered, all gets recovered back into the peritubular capillaries, and this recovery is going to be happening here in the proximal convoluted tubules. Now, if you're diabetic and you have high blood sugar, you have filtered a lot of blood sugar, right? And we had said in this proximal convoluted tubule, we're going to have active transport structures that are going to be pumping the glucose back into the peritubular capillaries. But if you have real high blood sugar, it can't keep up with it. And so some of the glucose, rather than being collected and transported back into the circulatory system, some of it leaves out as urine. Now, what happens if you have diabetes? People that have diabetes tend to be dehydrated, and it's called a diuresis, is what they call that. And what did we say? Osmosis is the movement of water in response through a membrane. It's a passive process, right? That is the water follows, moves towards high concentrations of solute. And so people that have diabetes have glucose in their urine, and they have a high volume of urine as a result of that. And that is a process called diuresis. and diuresis. It's on slide number 5. It says, yeah. So diuresis comes from having high blood sugar because you can't recover all of it that was filtered. Now, you're also going to be actively transporting sodium. And maybe you remember from A&P1 that we said water loves sodium. And so we'll talk about how we're going to be actively recovering sodium, and we're going to talk about a special function of the loop of the nephron in the next video, and that has to do with recovery of water. If you look at the amount of water that is filtered every day, it's huge relative to the amount that you lose as urine. And we'll talk about how that is a special function of this part of the nephron called the loop of the nephron.